Hey everybody, today I will do another video, and today we will still do binary numbers, but we will do fractional binaries conversion, right? So let's say, for example, that you have a number to convert from fractional binary to a decimal, and you have some number like 0.0 yeah, so let's say they have a 0.01011, right? So when we convert this from decimal to binary, we go, remember when we started from 0 to the left, right? And we count the powers of 0, right? We count the power of 0 starting from 2 to the 0 power, to the 1 power, to the second power, and so forth, to the left. Now we're going to the right. Now we're going from this decimal point here to the right. And because we have to divide by the exponential type of it, we start from 1, right? Because technically, you know what, let me rephrase it, right? Because we go into the left and decreasing powers, right? We actually going to, yes, we go into the right from the decreasing power. We start from -1. So the power is going to be the first power, the first exponent is going to be -1. So in this case, I got a 1, 2, 3, 4 digits, right? So I start like this, right? So actually, let me put this right here. Alright, so and the number is 0.01011, right? Now let's say that so we start from left to right, right? And the number is 0.1011, right? Now what do I do here? I need to convert this to a decimal, right? So I do 2, right? Base 2 to the -1 plus, right? Plus 0. Well, this is here, the next power is going to be 2 to the -2, but remember you have a 0 power, so you don't even have to worry about it. But if you do want to worry about it, and you want to just do it like this, put it like this, right? Put a parenthesis around, and then multiply in the number, the base, right? And do 2 to the -2, right? Well, you know, if you multiply those numbers, it's going to give you 0 anyway, right? And then plus 2 to the -3, right? That is this one, right? I got that one, that one, that one, and then I gotta do the last one, which is plus 2 to the -4, right? Now remember from algebra that we actually, when we did these numbers like this, right? This is over 1. Every single one of them is over 1. So here we know that it's 0, right? That is a 0 right there. So we have to do 1 to the power of 1. See, I just change the exponent, make it negative, and bring it down. Make it positive, I'm sorry, bring it down. Plus this one, which is 1 over 2 to the third power, make a positive, bring it out, put it over 1, plus 1 over 2 to the fourth power, right? See, that is the number. Now, let's do the math. Let's do what we get out of that, right? We know here we get 1/2, right? So this is 0.5 plus, and that's here is, this is 8, right? So 1 over 8 just, right? And then here is 1 over 16th, right? So these are the numbers, okay? So you get 0.5 plus 0.125 plus point 0.0625, right? So now you add those numbers and you get plus 0.5 plus 1.25, oops, plus 0.25. Okay, and is equal to 0.6875 base. This is base 10. Okay, so that's how you do it. That's how you go from fractional binary to a decimal, right? Now, let's say, for example, that you have a number here, right? You know, you have a number, like, for example, you had a number in front of it, right? In front of this number, and instead of like having point, just a decimal, just a fractional binary, you will have something like 10 1 0 1 1. Now it's easy because all you have to do is convert this to a decimal. Either you memorize it or you work it out, whatever. But that we already did in the last couple of videos. Convert that and plus that, right? So you will still get a fractional decimal, right? And all you have to do in this case is just go to the chart and come out with 10, right? I meant 1 0 1 0, right? 1 0 1 0, right? And decimal 1 0 1 0, you come into 10 and you can actually just write the answer right there, right? Or you can put, write it as in hex, it's equal to A, right? So that's why I'm not going through that, because it's not really difficult, right? So okay, so let's do the reverse on something like this, right? So that is from binary to fractional binary to a decimal. Let's do decimal. Let's do decimal to binary, right? So now we're going from decimal to binary, right? And we will see one quick example. Alright, so now we do this, right? So now, let's say, for example, that you have a number, let's say, for example, that you have a number like this, 0.03125, right? Base 10, this is base 10, this is decimal, right? We want to go to binary, right? Okay, so then remember when we actually convert binary to decimal to binary, we divide by 2, right? We divide by 2. Now here we will multiply by 2, right? So we will multiply this by 2, get a number, and then go and, just so forth and so forth, right? So let's say, for example, right, I take this number, right, and I say 0.3125 times 2, right? I am multiplying by 2, right? When you have a decimal, you want to go to binary, you multiply by 2. Okay? So you multiply that by 2 and you get 0.31125 times 2. Right? That is equal to 0.625, right? Now, look at this. What is the carry? This is the carry. Carry. Alright? So that one right there is a 0, right? So the first number is 0. Now take this number again here, right? And bring it here. Alright? And it says 0.625 times 2, right? So now take that times 2 is equal to 1.25, right? Put this one here because this is the carry. Whatever I am getting to the left of the decimal point is a carry, so I put a 1 in there. So it's 1, right? Now, let's do, now I got, and remember that I will just multiply the fractional part, alright, by 2. In this case, I'm not going to do 1.25, I will do just, I will do 0.25 times 2. So in this case, it's going to be 0.25 times 2, right? So 0.25 times 2, okay, so of course that's 0.5, right? So, yeah, 0.5, right? So now this is the carry again, so it's 0, right? And then let's multiply that 0.5 times 2, right? And that is equal to, of course, 1, right? So I'm just checking, right? That's 1, right? Now, that is the answer. Now, I don't have any more remainders here, right? Because the answer is 1. So I don't have any more remainders. So therefore, I stop here, right? So I stop there. Now, what is the answer? Now, in this case, you go down. Okay, so this is the most significant bit. This is the less significant bit. So this is MSB. This is the LSB. Right? So, okay, so now what would be the answer? Well, the answer will be that 0.3125 base 10 is equivalent to, so in this case I am going down, right? So I am reading like this. So it's going to be 0, 1, 0, 1. So it's going to be 0 point. Remember, I have a point too. There's another thing that I have to remember because I am dealing with decimal. So it's going to be point 1 or 1. Alright? So that is the answer for that. Alright, this is a quick video on this part that I have not, I didn't cover yet. I think it was a good idea to do it. In the next video, probably I will do some octal, and also I would like to let my viewers know that with these tutorials I will not be consistent in everything like a class, I will not be like going through everything that has to do with digital logic, because I'm not gonna be able to cover all the kernel maps and logic gates and all that stuff. I am just trying to give you the basic, just in case you take in a class. Maybe it might be a CCNA class, license that you want to get, or might be some type of networking, class, or might be a digital logic class. But I just want to do the basics so you have an understanding how to convert back and forth on different numbering systems, right? Thank you for watching. This is the video for today. Thank you for watching.